have you to start. Welcome, everybody. It is April 27, 2026, and this is our pre-anti-penultimate Astro Cafe of the season. Figure that one out. Anyway, my name's Randy Enkin, and we have items from Marjie. Marjie's here. Good. Chris. Dave. We're going to talk about the IAD. If there's interest, I have a couple of other things, but we are going to start with Vince. And I'm going to take the screen and put up my screen. Come on, come on. Here we go. Share. And I'm going to click on this guy. And can I maximize it? I can blow it up. Oh, but I stopped it from doing its thing. Anyway, talk to us, Vince.
You're muted, Vince.
Oh, you're muted. If you've been talking this whole time, we haven't heard a word of it.
I guess it helps if I unmute myself. So that was my first official act as the newly minted MIC up at the Hill. To use the 120 Takahashi to do a time lapse of Jupiter. So that is a time lapse stack of Jupiter as of the last night that we were out there.
How long?
That was an hour. And each frame is 120 seconds.
Cool.
Yeah.
And do you know the moons that are off on the right?
Oh, we worked it out, didn't we? It was it was Europa and Callisto, I think.
Io and Europa.
Io and Europa. I stand corrected.
And those are the two innermost, right?
Yeah.
Okay, so because they're moving pretty fast.
They're moving, yeah, and they're actually moving apart from each other.
So the one that's moving faster would be Io.
Yeah.
Well, that is stunning, and you can see so much detail on the planet.
Yeah. Yeah. So that was with my own planetary camera that I hooked up, and I just ran it off recorded off my own laptop.
Okay, now you said something really important. You are a newly minted member in charge.
Yes, I am.
You get to tell us what is the process like and why should other people follow in your footsteps?
The process is you have to become an active observer and then attend a few times and learn how things work and listen very very carefully to Reg's every instruction and be very meticulous and checklisty about things and learn how to operate things, and then eventually when you're trusted, you get your own code and key, and then you will probably find me out there most clear nights this summer. I will definitely be posting to the list probably almost every night. We'll see how much energy I have, but yeah, that's my plans.
Do you have a project in mind?
Um, I've got several projects. I think project number one is getting familiar with the equipment and learning how to use it. Um, beyond the point of safe operation, which I'm fairly confident at this point, but actually learning to use it at a performance level. So, um, that's my project in the short term. In the longer term, I want to do some fairly long period deep sky photography with it, especially if we get that filter box going. I want to see what I can do with a mount that isn't shaking all the time and whatnot.
Well, that's very, very good news, Vince.
I interject, I say Vince is a very apt pupil and he quickly mastered everything and he's diligent and obedient with the checklist. And we're very happy to have him on board and look forward to many happy steps.
Thank you, Reg. I guess that's what happens when you give a search and rescue pilot a checklist. We kind of take those things seriously.
Just passing around our cookies here,
Oh, okay.
and my mouth is full.
With that, I've got to go hop off. I'd love to hang out with you guys, but my son desperately needs me to help him finish his capstone project.
And I want everybody to know that Joe posts these meetings every week, which is an amazing service. And we appreciate it so much. And so when you can't join us, you can still see. And here's Kathy. Everything is good. Okay. Now, I think it's time for Chris to talk about New Zealand.
Okay, thanks, Randy. This is just a quick presentation on something I learned when I was there, something I didn't know about, and something I never actually even thought about. So I just show you a quick few slides, though. And let's see if this will work there. No, of course, it never works when you do it that way. Okay, there we go. Okay, so I found out when I was there that New Zealand has in effect a second New Year's Day. And I knew nothing about that. And so I wanted to look into it and find out more. But just a little bit of background. If you look at if there are groups, and typically in the temperate world, we do this. We have a time where we might celebrate New Year, and that seems to be most often associated with the winter solstice. So you have a cooler or cold period, and then you have a rebirth. And for example, local example here is the Wasanic moons. I've given the URL down at the bottom of where these came from, but the moon in January is, I won't try and pronounce, I guess it's Ninyin, but I don't know how to say the ends with the underline, or the moon of the child is in January's, typically, if you look at how it would be with our calendar. And this is the description, and somebody has drawn a representation of it. And it just explains it here. So it's a time of rebirth. There's edible shoots, and the moon's yellow hair is the returning light. So that kind of raised an interesting question when I thought about it. So what happens if you live in a southern hemisphere country and it's temperate, like New Zealand, Aotearoa, New Zealand, and you're using the Gregorian calendar? Because all of a sudden you're faced with a New Year's celebration in summer, right? Because January the 1st is in the Southern Hemisphere's summer. And I wondered, well, and then I found out about what they've done about it, basically. But, was that correct? Is that what the Maori have for long-term recognized? And no, like the Wasanic, the Maori do have a celebration, but it's actually in the New Zealand midwinter, again associated with their winter solstice and not their summer solstice. And this has an astronomical reference because one of the main things it's marked by is the reappearance of the Matariki star cluster, which we know as the Pleiades, in the early morning sky. And so on the Gregorian calendar, this occurs from late June to early July. But due to some difference between the calendar that the Maori traditionally used and the Gregorian calendar, this day actually floats, so that's why it says late June to early July. So what has happened since then is the government of Aotearoa, New Zealand, enacted Matariki Day, and the first one was celebrated in 2022 on June 24th. And a Matariki advisory committee was struck, and I think they've dated the day for the next 40 years anyway, so I think it's something like that. And they do hold it on a Friday, somewhat different than a lot of the other statutory holidays that are in the calendar, which are often on Mondays. But they wanted to do this to encourage people traveling to spend time with their family. And so this year is going to be a later day, and it's going to be July the 10th. So in fact, New Zealand has 2 New Year's days. So that was what I had put together.
Thank you. So what other New Year's days do you know about?
Well, I think most of the North American indigenous groups did celebrate something probably more like in the winter, right? Like here. I think that's the case. I didn't look into any more, but
Because the Jewish calendar, it's mid to late September.
right.
Is Rosh Hashanah, head of the year. But it's really, I don't understand, but it is explicitly the first day of the 7th month of this lunar calendar.
Right.
Why that's the new year is the 7th month was something that I don't understand. It seems peculiar that you don't call, what's it called, a Daraj? Is that it? Anyway, the month that starts with the head of the year is considered the 7th month of the year.
Yeah. Well, there was probably some very significant reason for doing that maybe has been lost. And
Or
again,
not
that shows.
lost, I just don't know it.
Okay, lost to you. And but I was going to say there's an example because, of course, those writings would have come from a much less temperate area of the world, let's say, right?
Mhm.
So there is a winter in that part of the world, but maybe not quite as much of a winter as further north. I don't know.
And then there's the whole Asian world has
Yeah.
their February, late January
Hmm.
full moon or new moon. I think it's a full moon.
Yes.
Is
Yeah,
their new.
certainly in China, that is a huge event, right? And I'm not sure about Japan. We need Brian here, but I guess he's away.
No, Japan uses the same,
Same one? Hmm.
but they argue about. I think it's the actual animals of their 12 years are not the same.
Because one of the things that's interesting, I hadn't realized because I'd never really looked at the map, because you tend to think of New Zealand and Australia being kind of side by side, but they're not, right? New Zealand is quite a lot further south
Oh yeah.
than Australia. So if New Zealand were off the coast here, the tip of the South Island would be somewhere in southern Washington state, and the top of the North Island, because of course it would have to be the other way around, would be somewhere around Los Angeles. So that's roughly where New Zealand fits.
Okay.
Whereas New Zealand is a lot further, but not a lot closer to the equator than that. So when you're in the southern part of the South Island, you're pretty much more in line. I think you're even south of Tasmania when you're in somewhere like Dunedin, and so it's quite interesting to think that it's because it's one of the, if you look around the southern hemisphere, it's really only the southern part of South America that gets that far south as well, and in fact goes further south. So when you're in Tierra del Fuego, you are much, much further away from the equator. But yeah, so it's interesting. So New Zealand has a kind of winter like the Pacific coast does, but further south of here, I guess. A noticeable winter.
I'm just pulling in Google Earth so that we can fly around a bit.
Yeah.
Okay, come on. How do I do this? I go share and here and what do we do? View.
You do need to rotate it a bit. Yeah.
Here we go.
Oh, there you go. Yeah. So I think when you're in Auckland, for example, you're about on line with Sydney, I think,
Yeah.
which of course is fairly far south in Australia.
Well, that's good to know. I hadn't actually paid much attention to that.
No, I had no idea before we went, and it was kind of like, well, how far south are we? And when we were driving, I had an app that tells you what your longitude and latitude are, and we crossed 46, driving south from Dunedin, and then we started going north again.
Right. Very good.
Oh. But so it was interesting to see that. It was, it's because otherwise it was really out of, really out of sync with how things have been and still are.
Margie, you have a segment you would like to share.
I have. Just a minute. Share. Okay. Now. Um. Okay, click on desktop 1. Desktop 1. Press share. There we go. Okay. All right. Can you see my screen?
Yeah.
Somebody answer yes or no, please.
Yes.
Oh, thank you. Thank you. Oh, thank
We were
you.
Quiet.
It's awfully quiet back there. Yeah. All right. So one of the advantages of working at the volunteering at the welcome table at Astronomy Day is receiving questions. And there were 2 questions I received to which I either did not know the answer or was not very sure of the answer. So let me see if I can go ahead. So here we go. There we go. All right. So we know that we are the Royal Astronomical Society of Canada, and we have a logo, Quoducit Urania, which means where the muse of astronomy leads. We have a mission statement. We are devoted to the advancement of astronomy and related sciences. We have 30 local centers of RASC across Canada. I didn't know for sure how many there were, but we have 30. And the furthest north one is in Whitehorse. Here's a really interesting question to which I did not know the answer. How are we royal? The Royal Astronomical Society of Canada includes royal in its name because it received a royal charter from King Edward VII. 1901 to 1910 was his reign. In 1903. RASC was officially founded in 1868 as an amateur club in Toronto. The organization was granted this title of Royal to recognize its contribution to science, formally elevating its status. That's how we became Royal. And just in case you don't know the origin of RASC, it started in Toronto, 1868, with a group of friends. They called themselves the Toronto Astronomical Club. The club was formally incorporated as the Astronomical and Physical Society of Toronto in 1890. And this is considered the founding date of the society. We grew over time, and by 1900, surrounding communities were affiliated with the group. On March the 3rd, 1903, the club was renamed the Royal Astronomical Society of Canada after petitioning King Edward VII to use the prefix Royal in the group's name. At the time, the group had 120 members. Today, we have 5,000. That's all.
Well, thank you.
Didn't know that.
I didn't know that. What were some questions that you knew?
Oh, I knew many. I knew many answers to many questions.
So like what?
Oh, what does RASC do? You know, how often do you meet? Those kinds of questions. But I wasn't totally sure of the number of clubs. I was estimating more, and I certainly didn't know where Royal came from.
Mhm.
Now we know.
My favorite thing I got, I was at the stellarium table and a guy said, "You can change the date." I said, "Yes, I can." So he told me to choose, something in 2005. And I said, "Where?" And he said, "Mexico City." It was his birthday. Anyway, I told Eva this at dinner, and she said, I was interested in the astrological stuff. It didn't come up. I think he was just curious to see what's on his birthday, but is that the sort of thing that somebody wants to know their astrological whatever would be interested in seeing what their sky is that night?
No.
I don't know about the astrological, but I know Jill has said when she's on Stellarium, people will often ask, show me what the sky looked like on my birthday.
Ah,
Mm.
okay. It came out of the blue while I was there.
Mm.
Anyway, Margie, you have given us the perfect segue to
Oops.
go to Zenfolio. And come on. I go share. Screen. Share. And we go to Zenfolio. And I'm going to kind of skip along, and you guys have to say stop or notice or whatever as we're going along, or we're just going to be quiet now. Although I love this as an astronomical picture, Wyman. Smiling Bill, smiling Jeff, smiling Alex. That's great. The children's table at the back, I think, worked really well.
Yeah, it was busy.
It was very busy. Look at that.
Randy, are these Wyman's pictures?
Are they all Wyman's pictures is my question. They're mostly Wyman's. Did
Okay,
anybody else submit?
I believe they're all Wyman's actually.
Yeah. Well,
We are
yeah.
so fortunate.
Thank you, Wyman. You were very busy that day.
Randy, click on the slideshow link on the top right corner.
Oh,
Makes everything bigger.
I can do that. And where's
Yeah, and
my
you can
arrow?
you can hit the the expand button on the top right corner too if you want to. It gets even bigger.
What am I
Just
looking
wait.
at?
Just wave your mouse over the window.
Top
Top.
right corner.
There's a four-way arrow. There you go.
Okay. Oh, and now it's just auto forwarding. That was a very cute thing that Chris and Phil had. The giveaway table, my goodness. How much did we have to take away from there, Lauri?
All that was left was one small, like not even a quarter of a bin of magazines. And that table was overflowing at the beginning of the day with books and everything.
Yeah. So I feel
Thanks,
very
Dan.
motivated to get rid of some of my books there next year.
Yes, I've had other people say that David, I think, mentioned that he's going to donate stuff next year too. But yes, we'll fill up another table. We'll give it all away again.
Yeah, there's definitely a lot of people walking around with books and maps and all sorts of things.
We're
Yep.
so pleased James came to
Yeah.
the staff a HAA's table. And our Artemis table. Oh, look at that face. Smiling faces. That's great. And the sun definitely put on a show for us.
And you can see how many people we had out there, because I was
Yeah,
still
okay,
setting
so-
up. But I mean,
Okay.
there's
Actually,
Vince and
could we pause on the solar thing? I didn't really hear a fulsome report from maybe Chris or somebody who was actually out there.
Stop.
There's
Oh,
a
there
pause
it is at
button
the
there.
bottom. Okay. Phew.
so
Okay.
I think
Chris
there
and
were
Alex, how are things outside?
so I think there were 8 of us there, if I got my count correctly. And we had kind of an equal amount of equipment. So you can see in this photograph, Jim Cox bent over on his personal telescope that was on that table. And Dan Hogan showing his personal telescope that he got from Sid's collection. And he's already bought a solar filter for it and a 90-degree diagonal. And who's next? Dave, I can never remember his last name, showing off the Lunt. And then Alex is up his ladder. And can't remember who's behind him, and Ken under his umbrella. And I'm there with my double there. You can see my 2 telescopes there. So yeah, we had a big crew out in Leanne with the Dob. So yeah, it was I think it worked very well.
You had
So
lots
I
of
did
telescopes
make-
out there.
Yeah,
I
we
make
have
it-
both club hydrogen alphas, Ken's hydrogen alpha, my hydrogen alpha, and then a series of the white light filters.
Chris, were there any of the students coming to help you, like Kamosen or?
No, not this
No.
year. So it was purely our members
Okay.
doing it this year. That would be nice to have. I did talk to John at Vic High, but he's had some family health issues in the last year, so he hopes to participate in a future year.
Right.
Yeah, I had a correspondence with them also. That's sounding like things are looking better for Oak Bay High.
That's Vic High.
Vic High, sorry.
And I don't know, Camosun had a solar telescope, but not sure quite how engaged they are at the moment.
Well, they were inside.
Okay.
There, and I didn't hear from Tristenberg that the solar telescope was working. They never asked about it. So, or
Yeah. And I
offered
was
any.
talking to Ben because the Lunt 35 is one of the best for outreach. And so hopefully the friends will bring theirs next year.
I want to say that I did counts several times, like about once an hour, and I was seeing like 14 people outside at a time. and my average inside was 43. And then the audiences were well, average of 30, but when Chris gave his Artemis talk, there were 53 people there. We had to bring in extra chairs. I love this picture. The person who made this model of the plastic dome did such an extraordinary job. It is so detailed. And Amy didn't know who did it. She said they just found it on the shelf there.
It was sitting inside the gift shop, windows, and has been there for the whole time that the gift shop has been open, but nobody knows anything about it. So
It looks like it's in really good shape, although I noticed the looks like the blue tape around the windows
Tape is coming
curling
up,
up a
yeah.
bit. Yeah.
That's
So
the only
maybe a
thing.
bit of restoration by somebody who's got model making skills. Haha.
Yeah, so I figured I averaged 43 in the main hall. And if people are there for
stop for a minute there. Can you stop? Can you go back? Oh, maybe you can't
Absolutely.
go back.
I can go back.
Yes, I just want to say that these three people stayed the entire time, and that we had three people on the Ask an Astronomer table the whole day. 3 women. Yay.
Yep.
Yeah.
And they have good answers?
Yes.
Did you challenge them?
Yes.
You did.
Yeah, that was another thing that was neat. The solar team, just about everybody was there the whole time. So,
Yeah.
it's a long
And
day.
the little robots.
I
The little robot
I asked them the real tough question just out of the blur because I went by and said hi, and they said, "Do you have any questions for us?" So off the top of my head, I said, "When will we discover alien life?" And I was very impressed with their answers. Like
When will
they
they
were like right
discover
into
what?
it. Like oh, they were like way in tune with possibilities as to what we and very positive that they will learn about alien life in their lifetime, as opposed to me, which I kind of am past that now.
Well, that's a nice one.
And how many volunteers did we have?
Oh, good question.
Oh, a lot.
I could count, but probably 50 anyway.
Wow.
Yeah, sure. Yeah.
Yeah, at least.
Okay, so here's our speakers. Unfortunately, Dennis had a small crowd. It was too early, I guess, but lots of pictures that I've never seen. He's digitizing more and more of these pictures, and then he loves to figure out exactly where the picture was taken, and he's really doing a wonderful job for the community that way. Chris, as I said, had a full to bursting audience in at 11:30. Lauren Harrison, wonderful talk, and she really it was lots of very good biographies, but then she really talked about the discrimination and what has to happen to bring parity in astronomy. And then Megan, I learned so much about her whole journey, starting with a really fuzzy picture of the moon with her iPhone through her first telescope, all the way to her amazing stuff that she's doing now with this bespoke telescope that she and her sweetie have been designing. So, 4 really wonderful talks. I want to say my guess is 43 people on average in visitors in the hall, and if everybody spends half an hour there were 10 half hours, so that's 430. And then Jeff, are you here, Jeff? Anyway, he had a clicker, and I don't like notes on how he got his 350, but so let's say we had 400 people this year.
Which is
It
down from
wasn't-
other years.
maybe down. It wasn't ever boring. It was interesting. It did go down just as the 1 o'clock IMAX was taking
Yes.
place.
Yeah,
That
a
was-
lot of people were coming by to go to that. I know that.
Yeah.
What was the 1 o'clock IMAX? It was obviously very popular.
Yeah.
I think they all were. I think that they did really well with the IMAX shows that
Very,
day.
I think it might have been the Planet Earth, the one at
Ah.
1 o'clock.
Yeah.
Yeah.
But a number of
Yeah.
people outside said, "Oh, I've got to get going because my IMAX show is going to start."
Okay.
There were a lot of people who came to the for the IMAX that did not know about the Astronomy Day activities.
No.
Oh, okay.
And
Well-
there was a cruise ship here on Saturday, so we did have some visitors from that.
Yes, as well as Port Angeles and
Yeah.
regular Washington State visitors too. I had a lot of people take books wondering if they could fit it into their luggage. Posters as well. They still took them, but whether or not they made it home with them, I don't know.
I was interviewed on CFAX on Tuesday, and a couple of people told me that they heard me on the radio.
But I think it was good having so many people and telescopes outside because there weren't long lineups.
Yes.
So people could come and find a telescope to look through. So probably a good idea if the weather forecast is good. Because as you can see in that picture, there were some telescopes with nobody there, right?
I wonder if we could have timed up with the race the next day. There were 15,000 people downtown on
Oh
Sunday.
yeah, that was busy. Well, we've had
that wouldn't have been
Astronomy
a good
Day.
idea.
Yeah, we've had Astronomy Day on the same day as the TC10K.
Oh, really?
Because I was down there it was one we had at UVic when the museum was closed. So I was down at a TC10K in the morning and Astronomy Day in the afternoon. So, but that was the UVic one, the most recent UVic one.
Yeah. Yeah, I don't think that would be a great combo competition wise.
Okay.
Just getting back to Marjie's talk, I did post a link in the chat to Peter Broughton's book on the history of RASC that was published in 1994. And it's because it's out of print, it's available as a PDF if you want to read it.
Now I'm going to pin our picture. How do I do that? Are we big now on your screens?
Mm-hmm. Yes.
So
No.
No, we're not.
Yeah.
Well, only if we allow it to be. I have mine on gallery view at the moment, so you're small. But having you, as you've hinted at that, I will change it and have you large.
Oh no, I can. Sorry, I can do this. Hold on. I can say pin for everybody. I saw that. Where did I see that? Spotlight for everybody. There we go. So it was very clear that many of us wore our t-shirts and they worked very well. And so it motivated me. We have more chocolate. That's good. Alex just arrived. It motivated me to do another order of t-shirts. What I did is for the Star Party last year, I ordered 25 because they were cheaper if you bought 25. And I said, you choose the size profiles. And so we have a whole bunch of small ones left, because who cares? And then we didn't get enough of the big ones. So this time I'm going to do it by order. So people have to email me. I've had a few before, and I will confirm with those people that they have asked for a size. I think the black looks very good. It needs a dark color, so I've recommended the dark blue and the dark green. But if you want to have a yellow shirt, I'm not going to stop you. So I need a size, I need the color, and we'll do these again. And they're so good for the outreach, for the Star Party, for the Sandwich Fair, for the International Astronomy Day. So I will put it out as an email by itself. I've already got one order for putting it at the bottom of the Astro Cafe announcement. But I think they look very good, and they are stunning seeing our group together with the t-shirt on. How much? Well, we charge $25. I'm going to try to keep that. I'm going to remove the spotlight now. Help. There we go. And here too. So remove pin. There we go. Okay, so I'm getting emails. That's excellent. I will again, I'll follow up and I'll place the order, and then we'll get a bunch more. Very good.
Randy, can I just say,
Yes.
the water is hot.
Oh, and there's coffee too, I bet.
There is, of course.
Awesome. Okay, well, I'm going to ask Dave Payne to talk about the Astrophotography SIG project, and I'm going to get myself some coffee.
Sure, I was just sending you an email. But I will share my screen and get that out of the way. Am I sharing?
Yes.
Okay, great. So, as part of the astrophotography SIG, we often share our images and we talk about them. And we talk about how we took them and also how we processed them and all sorts of fun things like that. But I had noticed a couple of groups who had posted images where they had done a collaboration. And it's kind of interesting because in order to get a bunch of detail and at various field of view, you generally have to spend a lot of nights with one setup, and it's only when you spend a lot of nights with one setup do you get the details in the background of these images. But if you have a multiple bunch of people taking images at the same time, you only have to share the data. You only have to spend a fraction of that time actually taking the images yourself. And together, the other thing that's come about is processing ability. We can actually, with modern processing techniques, we can take a bunch of images taken with different focal length telescopes, different sizes of camera sensors and different resolutions of camera sensors, and merge them into one photograph. Sometimes an image will contain interesting things that you want to zoom in, but you want a wider field of view, so you can get the detail from one setup and merge it with the general background from another setup. So we thought it would be interesting if we tried this out. And we know we're all come from different ways of doing this, but so we kind of made up the rules as we're going along here. So we started this in February, and the intent was that we would take our images in March, process them in April, and right about now we'd have several different people's interpretation of the combined data that we gathered. But March wasn't very good weather, and so we extended it a month, and April didn't turn out very well either. So we're now, with the clear skies we're getting recently, at least now a lot of us are getting out there and actually taking pictures. And one target, we have to pick a target that's up in the sky, fairly high in the sky, and it is galaxy season. So as the first target, we chose the Coma Galaxy Cluster. It's a cluster of galaxies that's 320 odd million light years away. So it's very, very far. And a lot of us consider it the most interesting cluster in the sky. More famous is the Virgo cluster. It's a large cluster, but it contains mainly elliptical type galaxies, just like the two galaxies in the very center of the Coma cluster. They're basically round and really boring. So the Coma cluster, and it's called the Coma cluster because it's in Coma Berenices. If I got the pronunciation right. But it's got a heck of a lot of spirals. And so if you got a powerful telescope that's good for zooming in, you can zoom in any one of these little interesting spirals that are around here. And you can spend a lot of time just looking in and looking at these spiral galaxies, and a lot of them have collided with one another because they're all kinds of shapes, and some of them are face on, and some of them are edge on, and it's just a nice thing in a wide field of view that you can go exploring. So it would be nice if we had an image where you could pick a certain area, and the more you zoom in, you get more detail on it.
Oh, so are people being requested to focus at different parts of this field?
We're leaving that up to the individual. So what if you like, this is a fairly wide field of view for this one. But if someone's focused on that galaxy I pointed you, or any sort of area like this area here, we can incorporate the detail in a wide field of view. You will lose some of the detail by upscaling, but still it will improve how we see that portion of the galaxy. Now, a bit of a challenge will be to try and make it seamless so you don't see the edges of that stitched in zoomed area.
Right.
So there's all sorts of challenges to this, and we don't know the rules, but we're about having fun, and this is a lot about fun in the astrophotography group. And so hopefully we get a bunch of data this month, and then in late May and June, we can all do our hand-up processing. You can actually make several images if you want. Now, the data was all going to be shared from a common directory, and we should be able to see some dim stuff, as well as the galaxies themselves. Now, there is a little thing that I've been trying to keep to myself, because this image,
We'll keep it secret. This is fine.
I'm going to tell the secret because I'm going to let the cat out of the bag. So I took this picture last year. And I've included the data in the project, but I'm taking some more images now. But there is a light coming from this cluster, not directly from the galaxy, and it's a few percentages brighter than the actual background of the image. And in this image, you can see this light in between the galaxies, in and around the stars. And I've got a starless image. I used AI to take the stars out. But you can see that glow that's coming from all around. And this glow has been recorded. It's hard to capture, and I think you get a lot more detail if we had a lot more images to stack in this final images, in this final image. But there's a bunch of theories as to what you can actually see structure to a lot of it. And there's one little, I don't know if it comes across on the image. Can anyone see a faint green sort of?
Yes.
There, I try to put it in the center there. You can see that faint structure. So it might help to figure out what it is if we can bring it out from the background a little more without adding a whole bunch of noise. One theory is that it's given off by stars that have lost their way during a galaxy collision. It could also be just a combination of stars and gas that has kind of lost its way, the same sort of thing. But hopefully we can get a better sense of that background material with this project. So it's a real fun thing. I think it's really fun. Hopefully we pull it off. During the summer, we might switch to some nebular images, or we'll pass around who gets to choose the target. But that's all I have to say about that. So if you want to help us in the project,
That's interesting.
just sign up for the Astrophotography SIG, get on the letter, and you'll be invited to the next meeting. And we'll have some fun. We'll at least give you access to the data we take if you don't have the rig for yourself.
How many people do you know are participating in the project?
Well, everyone's keen. I'd say there's at least 6 or 7 of us doing it.
Fantastic.
And we're trying to get the Plaskett involved.
Oh, wow.
Hopefully we could get some images there. We've got Ken down with his Texas Observatory. Hopefully we can get some images out of him, and should be a lot of fun.
You guys are spectacular. That's super. Thank you so much.
You're welcome. I just gotta de-share the screen, so there.
And we can hope for a result in September.
Yes.
Hey.
You can hope for a result in September. I'm sure we're doing it wrong. But
well, that's great.
We'll find out how we're doing it wrong.
You'll never learn without doing it wrong.
That's right.
Science in action, David.
I think the whole thing, from the conception through the actual mechanics of it to the final result, it's perfect. I think this is awesome.
So what part do you think you're doing wrong? It's Bill.
Well, we're kind of saying, well, you can put the cluster in the center of your field of view if you want. You could take a mosaic if you wanted, with a more powerful, or you can just focus on one small area. We didn't set very many rules. We didn't set rules about sensor size or telescope size or anything
Filters?
like that. So we're kind of freewheeling it. So, and maybe we have to be a little more specific, but only if we have to be. We want to involve as many people and as much different equipment as possible.
Because then the stitching together might be difficult.
Yeah, you read about it, and the documentation all says it's possible. That doesn't necessarily mean it works well in practice.
Well, I remember a talk given whenever it was the GA was in Kelowna, so sometime within the last 20 years. Rajiv Gupta, I don't know if he's still at UBC or not. He was he was our president and editor of the handbook for a while and stuff like that. He'd created a program where it almost didn't matter, and he gave a talk on it at the GA, what you threw into like so you could scan film, you could anything, and you threw it all into this program, and it stacked it all up and aligned the stars and made it the image. So it didn't matter what it was digital film, and or the size of the scope or whatever. You would have been there, David.
I was, and that name of that program is Registar. I don't know. I think I still have a copy of it, but I don't know if it would run anymore. I'm not sure.
Because it was Rajiv's program, right?
It was.
Yeah.
Well, the whole thing knows how to interpret or upscale images, like your TV does that when it's showing you something.
Mm-hmm. Yeah, Registar didn't really care. Like you could have taken used different focal lengths. You could it would stretch things if it needed to. It did a lot of things.
The hard part is getting the background consistent.
You have to have a good registration method, I guess. Something has to be able to register too, right?
Yeah, I don't think that's an issue with plate solving. So it knows where every image is supposed to lie. But it's just picking your reference image and then combining everything to that. But the hard part will be getting a consistent background so you don't see the stitching together of the images. But like I'm just guessing because I don't know what problems we're going to run into and what we're not going to.
You know, I think in the worst case, one could just use similar scales and blend them together, and then take all similar scale things, do that, and then maybe figure out a way of blending those pieces.
Yeah.
Maybe you might have to use masks to do that, but
the whole goal here is to stay away from specificity. We don't want to tell people what telescope to use or what camera.
Well, that will definitely be the challenge.
Yeah.
So, Bill, Peter points out that you're wrong about it being the last 20 years because it was in 2005, so it was 21 years ago.
Oh, okay.
Long time ago.
And thanks to Peter for noticing that.
Just had a look to see there is still a Registar website, so I don't know.
Maybe it's still around.
It's still around.
I'll check into it. I'll have a look.
Another rabbit hole.
PixInsight does it. Cyril does it. They all do that.
I don't think that's a feature we need. I mean, there's existing software that already does that.
I have a piece of advice for Dave and his group. NRC at International Astronomy Day had they had about 6 different kinds of stickers. Don't know whether you saw them. They're very good. And I have one sticker on the back of my car now that says, "First coffee, then science." So, here you go, Dave.
Thank you.
Have coffee first.
That's a very good idea.
Oh, man.
Yeah, I like stickers too.
Yep, they better come back next year.
You saw my telescope, right?
Yeah.
I wondered where everybody was on the Saturday night. There were very few of us up on the deck at the
Yeah,
GAO.
you're right. You're right, Bill. I was surprised as well.
It
I don't
used to
know.
be fighting for space.
Yeah, but I think it was kind of, yeah, I don't know, maybe people were exhausted or something like that. But I had a good time that night. I got to show people the sun and the sun kind of rolling behind the hills. This one guy was just totally thrilled because he walked by at just the right time. And I said, "Look in here." And he says, "What is it?" I said, "You tell me. You look in here." And he saw a big round ball with these trees in front of it. And what's really so amazing is when the sun gets really close to the hillside, it's not just straight silhouette. They become almost like backlit, so they become frosted. So he got to see that. So that was cool. We looked at Venus as well.
And Randy, here's one for you. I got to show all sorts of people the craterlets in Plato.
Ah,
Ah, see, that's still on my list, Bill.
Yeah, well, you should have showed up.
I should have showed up.
They were easy for just people who had no idea. I said, look at this smooth bottom crater and look for little tiny white chips. And they were like, oh, you can see them. It was a perfect night for it.
actually, Randy, I want to add this. The night or a couple of nights before Astronomy Day, a few of us actually went out to Cattle Point to see if we could sort of advertise IAD. So a lot of us came out. I think Dan was there, I was there, Kirsten was there, I think Ken was there as well, and Vince as well. But what's so fun that night? I had brought the refractor and the Mac Cas, the 127 millimeter Mac Cas, and I had never noticed this before. But it was day 6 of the moon, and the all around the Sea of Serenity, there's this huge line of shadows because the sun is so low down. It's kind of almost lighting it from below. And I had never seen this stretch of shadows coming off of the crater wall before. And it was just stunning. Absolutely stunning. You know it probably, but I had never seen it or never noticed it.
Around day 6, thing that I
Day
really
6.
like is the Altai Mountains that surround,
Yeah.
what is it? Mari
Nectaris?
Nectaris, thank you. It's so good having Phil here.
But the shadows were just so dramatic. I just never seen them that way before.
That's great. Okay. Well, as I wrote in my letter, between the International Astronomy Day and I'm getting ready for a big talk at the General Assembly with Kirsten Vanstone, and I'll talk about that in another Astro Cafe. It's about the Lunar Eclipse Crater Timing Project. So I want everybody on August 22nd to participate in that. But we'll talk about that another time. So I didn't prepare a talk, but I did notice, I have to share for the 3rd or 4th time today. Boom. Yeah, in Sky and Telescope, there was this news item from this week about Proba 3. And I gave a talk about Proba 3 a while back. It's one of those, it's an engineering project, but they did something useful as they are working out the bugs. The goal is to produce a way for satellites to move in formation. Because, for example, you can make kind of a big interferometer if you can keep 2 satellites flying very accurately together so that the spacing doesn't change. And so what Proba 3 does is there's one of the satellites, which is basically a big disk, and the other one, which is a camera, and they fly 140 meters apart and produce a solar eclipse. But instead of lasting only a few minutes on Earth with the moon traveling in front of the sun, this one, every day they get 6 hours. Okay, so they get beautiful things like, let's look at this video here, and I can make it big. So Proba 2 takes pictures of the sun in ultraviolet, and SOHO can take a look out at like 3 solar radii away, but Proba 3 is in that zone between the edge of the sun and where a spaceship can just have its own little shadow, because you need that extra length there in order to be able to see really close to the sun. And so this is the sort of thing that they are able to do now, which is just beautiful. Anyway, it was launched over a year ago, and now the data is coming out, and they gave the article, and so I looked it up. It's this guy Zhukov. Gal, I don't know. Zhukov is the lead of this big team, and yeah, this is saying how big, how far is the thing making the shadow compared to the other ones. LASCO is part of SOHO, and you can see that it's way out here at 144 meters, and so it's able to do some imaging that you can't do otherwise. What else is in this paper? Yeah, this is what I wanted to show you. So this is the shadow maker. So it's called the occulter. The occulter. That sounds kind of witchcrafty, doesn't it?
Yes.
So it basically is just a circle, but it's got the thrusters and electronics and such that there's lots of laser rangefinders that gets it kind of in position, and then when it's actually producing a shadow on the coronagraph, that's this guy, then if any of the sunlight creeps out to the side, then it adjusts it. So it's always going to make sure that it's covering the camera here. This is always in shadow, and it's a cool idea. It's an orbit which at perigee, when it's closest to the Earth, it's 600 kilometers away, and when it's at apogee, at its furthest, it is 60,000 kilometers away. So there's a factor 100 between when, it just skims over the Earth, and here it is 100 times further away. But by Kepler's laws of planetary motion, this is where it spends all its time. So this whole thing is like a 20-hour orbit, but 6 hours of it is up here. And the reason that they actually do the fine-tuning up at the apogee is because the gravity between the two spaceships, there's no gradient there. There's no difference when you're far from the Earth. There's a lot of difference. They'll be traveling around the Earth at different speeds when they're really close, but when they're really far away, then the gravity is what they call flat. And so it doesn't take as much energy to have them fly in formation for this 6 hours, which they do every 20 hours. Apparently, they've had lots of trouble because they lost communication for a month, and the thing went cold, and it's come back now, but they haven't been working for the last while. So this is a graph which is kind of interesting. So as you go through the year, the required separation changes. So can anybody think why in July the two have to be flown 147 meters apart, but in January they're flown only got 142 meters apart? What's the difference? When is the Earth closest to the sun?
Summer,
Absolutely wrong.
January.
The sun is closest to the Earth in the northern hemisphere winter. It's so weird. It feels wrong. But when the Earth is closer to the sun, then the now why is the spacing smaller when the Earth is closer to the sun? That seems backwards to me. Anyway, that's a exercise for you to work on over the week. I don't have much else to say here. Yeah, so 20 hours is the orbital period. And there's that factor 100 between perigee and apogee. That's what the actual camera looks like. Anyway, it's this paper that just came out. So that was kind of how it works. And then this was the first results. And it really is just 1 6-hour period. No, it's 1 90-minute period. Look at that. In July. So, you know, this is the very, very first results that they're showing. Oh, that's right. It's good to do this over. Help me, what's going on? I'm in the wrong place. This is it. Oh, that was the movie that I showed you. I guess that's it. No, it's not. Okay. Look, I haven't prepared this. So there you go. That's what you get. An animation of this figure is available on the online. That's what I want you to see. This is the online version. And here we're allowed to hit click. And this we can make big. And so they're going into all this stuff about there's fast wind and there's slow wind. I'm going to go back to the PDF. I like PDFs better than online things. Like these are just looking at one little direction around the sun. So this is time versus distance. So you can measure the speed of these things coming off the sun. And so it's like 100 kilometers per second, 200, 400 kilometers per second. But there are also some really slow things. 14 kilometers per second. And this is part of the sun that nobody's been able to look at before, which I think is really cool. And again, I haven't read the paper. I just looked at the figures, but they're quite beautiful. And it's such a clever project. And again, it's an engineering thing just to see if they can fly things in formation. But then some clever person said, once you're doing that, what we'd really like is to do these 6-hour eclipses, which I just love. There we go. Any questions? Well, That's
just a
every.
comment, Randy. I was going to say regarding the where the Earth is versus our seasons probably works in our favor because otherwise, if were it the other way around, we probably have hotter summers and colder winters. So I always think it's a good thing that we're closer to the sun in the winter and further away in our summer. Just a thought.
Mhm. I don't know how much extra radiation or insulation we get because of perigee apogee. I know that it goes into the Milankovitch cycles that brings on the ice ages, but
Well, and getting back to the original presentation that I gave, there isn't a lot of land in the southern hemisphere comparatively, so
yeah.
it's hard to say what effect that actually has.
I remember when I discovered that the sun is closest to the Earth in January, thinking that's just wrong.
Well, we always have to tell people when we're giving our presentations, because if you ask about why there's seasons, they'll say it's because the sun is closer in the summertime and farther away in the winter.
Right.
So, you try to tell them no. So,
And how do you explain the seasons in a way that people understand? Because you can
you
get
get
into
the
the
kids,
weeds.
you get the kids to tilt. Yeah.
Tell us more.
Sorry. Well, no, I mean, like you have to get the kids to tilt, and then they have to tilt as they're going around the sun, and with a stuffy, and so your seasons are whether or not you're looking toward the sun, or whether you're toward the sun a little bit more, or away
That's
from the
really
sun a
good.
little bit more.
That's really good.
One
So I
of the
usually-
other things you can do is shine a light at a globe, because the globe's mounted at its correct angle. So if you shine it from the four sides, you can see the effect it has.
Yeah, we actually did that at the Stonehenge exhibit. Do you remember?
Yeah.
Lauri?
Yes.
We did that. And we actually had a tilting globe. So we just had a light from one side.
That's really good. Well, dear club, that's what's on the agenda. Oh, we got Lauri waving her hand frantically.
Yeah. Well, not frantically, just hello. Can I just talk? Can I just talk a little bit about the GA?
You figure out. Right.
Yes, I think you write it down.
Go ahead.
Sorry. So the GA is this coming weekend. And we have a wonderful speaker who is going to be doing the Helen Sawyer Hogg lecture on Saturday. For us, it will be Saturday afternoon. So she's going to be giving her talk at starting at around 7:00 Eastern time. So it'll be 4:00 for our time on Saturday, May the 2nd. This is an open public lecture. So anybody can come completely, but you must register for the webinar. And that is on the website. And on if you received your message today from the national office, it's right there first, second thing about registering for the Helen Sawyer Hogg lecture. And this is Amy Sarah Titel, who is going to be speaking on some of the lighter moments of being an astronaut, and some of the antics, and some of the jokes and things that happened when some of these guys were up in space at various times. So she's a young person who has done a lot of work in education and social media, and I think she should be quite fun to have. So that'll be 4:00 our time, but you do have to register for the seminar. Then on Sunday is when the annual general meeting and all the sessions take place. In order to be able to be part of that. You do have to register separately for the GA. So there's 2 different registration procedures. They only take about 1 minute per to do, and it costs $25 for a member to be for all day Sunday. And because again we're in the East, we start a little earlier, so we're starting at 9 o'clock in the morning. So it's 12 o'clock Eastern time, and then going through till about 3 o'clock, 2:30 or 3 o'clock or so in the afternoon. And we have some wonderful speakers that are going to be there, including our Reverend Randy Enkin going to be giving a presentation. David Payne is giving a presentation. Darren DeLorme, who is doing his presentation on all the work that he's doing on the virtual reality of the Plaskett telescope. He's going to be speaking. And then we have got Kirsten Pedersen, who is going to be giving a presentation on her on getting her explore the moon. So thank you. Randy, is that you putting that up?
Yep.
There we go. So there's like stream A and stream B. You can take one of them and just go through, or you can go between stream A and stream B. You'll be given when you register, you'll be given all of the different links to all the different programs, and then you just kind of flip in and out as you wish. And so if there's any other questions that anybody would like, I'll be happy to talk. We've got Samantha Lawler, who, if anybody was at Astro Cafe in January, she's going to be giving a little bit more of her work on the billionaire space race. And then also Wes Fraser is going to be giving his talk on the Rubin telescope as well. So hopefully everybody will get something that they might be able to take away from this. We'd love to be in person, but it just isn't yet to be, unfortunately. But maybe someday we'll be able to do that. Then the other thing that you may have noticed today, if you do get the little newsletter that comes on Mondays, we have got a new executive director that is taking over from Jenna Hines. And her name is, and I'm not sure whether it's Sandia or Sandhya, Mila Bethula, and she has her PhD and MSc, and is going to be bringing quite a bit of experience in terms of some of the leadership she has with different organizations. And she has been the one who's been tapped to be our new executive director. She started just late last week. And I'm sure we will be seeing her first at the General Assembly. I'm sure that she'll be part of that. And Jenna Hines will be coming back, and as a volunteer is going to be coming back as well to do some works for the General Assembly. So if anybody has any questions about that, I'll be happy to answer anything that you'd like. We hope all of you will be online at some point, either on the Saturday afternoon or so, and then Saturday during the day on Sunday.
I'm
Thanks,
just
everybody.
looking her up. It's interesting. Her PhD is in kinesiology, and her topic was concussions. So
yes, this concussion. Yeah,
she's
so
sounds like a very interesting person.
Wow, that's wonderful. Okay, and I didn't write down, but Dave Robinson, I'm very pleased, has a book review.
Very
And
quick.
I'm going to spotlight us for everybody so you can bring your book up to the camera. If I can just move this. The mouse is jerky. How come?
It's really important to have it close to the receiver, and so the computer and the mouse need to be close-ish together.
Okay, so book report, I just finished this. It's by Andy Weir. It's called Hail Mary. Andy Weir wrote the book The Martian that was turned into a movie. This has been turned into a movie and it's in the theaters right about now. It's the story of discovery that something is taking energy from the sun. And if it keeps going on, the sun will go cold enough that we'll all die and freeze up. They think it's a microbe. My wife, who is a microbiologist, says the microbiology in this is crap. But it's a good story. There's a little bit of relativistic physics, there's some math, there's some astronomy. It's a really good story. Basically about two creatures, a man and an alien, who meet somewhere to find out why this one star in our vicinity does not suffer from this problem. And the story goes from there. Quite entertaining. We haven't seen the movie yet, but we're probably going to go just to see what it's like.
It's going to be at the IMAX, so you can see Hail Mary in the IMAX.
There you go.
Yeah, tickets are like 3/4 sold out already.
Oh, we got it.
Yeah, they're going fast.
David Lee has his hand up.
I do. There's a couple of things. Yeah.
Definitely.
Wait.
Let's finish off with Hail Mary.
Yeah, I'm going to talk about that. I'm going to talk about that actually.
Oh, okay.
So I have actually already seen it, but I'm going to see it again at the IMAX, just so you know. Definitely worth seeing. It's definitely a revisioning of space. If you think of 2001 or Star Wars, Star Trek, nothing like that. So definitely worth seeing. Okay, so I would like to talk about a couple of things. Pardon me?
What's wrong with Star Trek?
Nothing wrong with them. It's just a different way of looking at space. No, those are classics too. I would never diss them. You know that. Okay, so there's a couple of things I want to tell you about. In addition to all these things that are going on the weekend, there's also a telescope clinic up at the Hill. So on May 2nd, there's going to be a few mechanics. I think Brock is joining us, CJ and I've forgotten the other person now. Brock, CJ, Bill, of course, Bill Weir. And then we're reprising our talks on types of optics and telescopes. We might add something on smart telescopes this year. And then Kirsten's going to tell us about some of her observing plans that she's created. And of course, Jill's going to tell us about binos. So please come up, and I really welcome people to come up as volunteers as well. So we have lots of different varieties of scopes up on the hill on that same night. So I don't know if anybody has any questions, but otherwise, please come.
And you can
always
watch,
need
you can watch
people.
the. Sorry.
We always need people to help at the RASC desk. It is a very important bit of our outreach.
Yeah. Please sign up. Even if you do it once all summer long, that would be just wonderful. Yeah.
Right.
Okay, so Lauri, go.
I was just going to say thanks to Susan Grady, who helped out at the registration desk, and Clinton Melissa Tupper, and they were busy. They were busy most of the evening there at the information desk for that. So thanks a lot, Susan. Then I just was also no, carry on. Go ahead. Sorry.
Well, that's it for this evening. Thank you so much. Even without a lot of preparation, we still filled in an hour and a half because you guys are so awesome. There's so many good things to talk about. Okay, I'm just waiting 2 seconds until Kathy comes back in so I can say thank you to her because she works very quietly, but she gets a whole bunch done with the hot drinks over here. There she is. Kathy, thank you for keeping us supplied with hot drinks. And with that, I'm going to say, turn off the spotlight. Turn off the spotlight. I thought we did have to turn off the spotlight. Is it not going around to everybody now? But in any case, I'm going to say good night, all. See you next week.
See you at the GA. Remember to sign
On
up.
Sunday at the GA. Learn all about the Crater Project.
Crater timings. That's right. Yes. Thanks. Thanks, Randy.
Good night.